Hello my dears, how are you all? So where we stopped yesterday, at what point we stopped yesterday? I think a problem we discussed, right? And part B and part A was there, so we successfully finished part B. That means I will read the question. Okay, I will read the question, my dear. Just focus on that. I think the question was, yes, GH is equal to K divided by S into S plus 2 into S plus 4. That question we discussed. We have to calculate the value of K for phase margin equal to 60 and gain margin equal to 20 dB. We successfully done without any doubt gain margin equal to 20 dB, but we got the value of K. We got that. What was the value of K? We got 4.8. I think this all of you got the same answer. And there was a small confusion in the part A, that is means phase margin equal to 60, and the confusion was actually made by me itself. I know that. That's why I'm going to correct it. Okay. Actually, the confusion was nothing, my dear. There was a point in the question. At which we got the equation like tan 30. We got the equation like tan 30 equal to what, my dear? 6 omega gc. 6 omega gc whole divided by 8 whole divided by 8 minus omega gc square whole divided by 8. Am I right? 8 minus omega gc square divided by 8, and 8 and 8 get cancelled. So I can write like tan 30. Tan 30 is equal to 6 omega gc divided by 8 minus omega gc square. So tan 30 is nothing but sin 30 by cos 30. Am I right, my dear? Sin 30 by cos 30. What is the value? Sin 30 is 1 by 2 divided by, it is nothing but root 3 by 2. 2 and 2 1 by root 3. Am I right? So I can write like 1 by root 3 equal to 6 omega gc divided by 8 minus omega gc square. I wrongly take, I am saying, I really apologize, I am wrong, I was wrongly taken simply 6 omega gc is equal to 1. It is wrong actually. The concept of mathematics is actually I violated. It is wrong. What I can do is the actual step or the actual way is nothing but, my dear, 8 minus this into this will be this into this. What I did etc. A by b equal to suppose z by d. I simply took A equal to C and B equal to D. It is wrong. Only I can take AD into AD equal to BC. This I can take. But I took wrongly yesterday 6 omega GC is equal to 1. That's wrong. So I can write only 8 minus omega GC square into 1 equal to 6 omega GC into root 3. This only I can take, my dear. This only I can take. Okay. So squaring both sides, it will form. Not squaring also. No need to square. Simply you can take like. Listen, my dear. Minus omega GC square plus 8 minus 6 omega GC root 3 equal to 0. Or other words, omega GC square minus plus 6 omega GC root 3 minus 8 is equal to 0. This is the second order quadratic equation, so that easily I can solve it, my dear. So what will be the omega GC? Omega GC is nothing but minus 6 root 3 plus or minus root of b square is nothing but root of b square 36 into 3 plus 4 into 8 4ac whole divided by 2 whole divided by 2. Now I will get a value of omega GC, my dear, omega GC, and keep that value there. If you solve this, you will get a value. Okay, and keep that value there. And what is the another condition we have? This omega GC this gain crossover frequency is nothing but, what is the gain crossover frequency, my dear? Gain crossover frequency is nothing but the frequency at which the magnitude of GH is equal to 1. That's called the gain crossover frequency. Huh? So I can say that what is the magnitude of GH, my dear? What was the magnitude of GH? The magnitude of GH was simply nothing but K divided by omega root of omega GC square plus 4 and root of omega GC square plus 16 equal to 1. Am I right? So this value of omega GC, right, you got a certain value. Actually in practical examination, I mean in original examination, this means inner roots is can be easily solvable roots may be given. Not this much complicated things will not be definitely asked. Okay, you just take a positive value only you can take for omega GC and substitute that omega GC here. So the only unknown here will be simply but K. So that K can be calculated by substituting the value of omega GC. That is the answer, my dear. That is the answer. So yesterday I wrongly took in the part B. I analyze it and okay, it's all wrong. But in part A, my dear, I wrongly took simply 6 omega GC equal to 1. So that's why I correct it. Okay, please note this. This is actually, it's a very difficult problem. So in between a deep mathematical concept will be there. Actually there is a chance of making mistake very easily. If you simply slightly careless, if you feel slight careless there, definitely there will be a wrong in the final answer. So please note it and make it correct. And once again I apologize, okay, because it's a mathematical concern, so I'm sorry for that. Okay, so let's come back to our topic, my dear. So that's all about the polar and gain margin, phase margin, polar plot, everything we completed. And next is nothing but the final topic in control system. It is nothing but Bode plot. So here also in Bode plot also we use open loop transfer function for analyzing. Here we are using open loop transfer function for analyzing, which means always you have a GH is equal to something. That format will be your question. That is it. So see polar plot and this Bode plot and gain margin and phase margin, everything, my dears, we are dealing with the open loop transfer function. And from that we are calculating the stability, everything for the closed loop system. Okay. And here what is this Bode plot means, which is nothing but, my dear, it is a graph between log 10 to the base omega versus magnitude in dB and log 10 to the base omega versus phase angle. So it is a graph between these. It is a graph between one log 10 to the base magnitude in dB and log 10 to the base omega versus phi, where omega is nothing but frequency. Omega is nothing but, my dear, frequency. And m in dB is nothing but magnitude in dB, which is nothing but, my dear, 20 log of 10 to the base m. M in dB is nothing but 20 log of m in dB. You can say like this: m, some quantity you have, convert it into dB means simply you take 20 log 10 to the base m. Okay. And before that, going to this concept, my dear, let me discuss something. What is the value of log 1? 0. You know this, right? Log 10 to the base 1 is equal to 0. And what is the value of log 10 to the base 10? 1. What is the value of log 10 to the base 1? It is not defined. It is not defined. And what is the value of log 10 to the base 0.1? Log of 10 to the base 0.1, which is nothing but log 10 to the base 0.1 means 10 raised to minus 1. Am I right, my dear? So which is nothing but minus 1 log 10 to the base 10, which is nothing but minus 1 simply. So you have to remember these values, my dear. You have to remember log 1 is equal to 0. Always the base is 10. Log 10 is equal to log 10 to the base 10 is equal to 1, or log x to the base x is equal to 1. Log 10 to the base 1 is not defined. Log 10 to the base 0. Sorry, my dear, this is 0. Log 10 to the base 0 na, log 10 to the base 0, it is not defined. Okay, log 1 is actually 0, but log 10 to the base 0 na, it is not defined. Log 10 to the base 0.1, it is nothing but log 10 to the base 10 raised to minus 1. 0.1 can be written by 10 raised to minus 1, which is equal to minus 1 log 10, and simply minus 1, my dears. Simply minus 1. And you have to note one more thing. That means, what is log 10 to the base 10? 1. Log 10 to the base 10 square 2. Log 10 to the base 10 cube 3. Log 10 to the base 10 raised to 4. See the beautiful, see the beauty of taking logarithm. Here it is nothing but, my dear, omega. When we are changing omega from 10 to 100, only the scale value is simply 1, changed by 1. If you change the omega value by again 100 to 1000, it is only simply changed by 1. That means this every decade you changing every decade. That means suppose you have omega equal to 10 raised to 1. It changed to omega equal to 10 raised to 4. Which means how many decades you changed means decades changed is nothing but, my dear, 4 minus 1 is equal to 3 decades you changed. 10 raised to 1 to 10 raised to 4 means into 10 raised to 3 will 4 mean 10 cube over 3 decades frequency you changed. That is the meaning. 3 decades frequency you changed. That is the case of log 10 to the base. Suppose log base is 2. Log 2 to the base 2 is nothing but, my dear, 1. Log 2 to the base 2 raised to 2 is nothing but, my dear, 2. Log 2 to the base 2 raised to 3 is nothing but, my dear, 3. Log 2 to the base 2 raised to 4 is nothing but, my dear, 4. Which means whenever you were going log 2 as the basic, my dear, log 2 as a basic. So can I tell me when omega changes from 2 raised to 4 to 2, how many octave you changed means simply 4 minus 1. 3, not octave, not decade, now it is called octave. 3 octave changes. 3 octave changes. So when log 10 is the basic, you have to say decade changes. When you have to take log 2 as the base, then you have to take octave change. So normally we take log 10 to the base because that is very easy. And why we are going for this log means a wide range of frequency can be accommodated in a very small scale, my dear. Simply now see, the scale will be 1 to 4 only now, 1 to 4. But in between that 1 to 4, what a range of frequency you changed. You changed the frequency from 10 to 10 raised to 4. That much of wide range of frequency you changed when you are using a log axis. Suppose you want to directly frequency versus magnitude graph now. Suppose this graph is simply frequency versus magnitude graph means you can't accommodate for very large range of frequency, my dear, because the scale is limited, the graph is limited now. A maximum 10 points will be there. So in between 10 points, how many frequency or how much frequency you can accommodate? There is a limit. But if you same time if you take log 10 to the base omega instead of omega or instead of frequency, if you take log 10 to the base frequency, a wide range of frequency can be accommodated, my dear. A wide range of frequency can be accommodated. That is the beauty of taking the logarithm, log 10 especially. But log 2 na, there is again a limit, not that much quantity na, but even though 2, 8, 16, 32, that range of frequency can be accommodated. But here see what a big range of frequency you can accommodate. 10, 100, 1000, 10,000, 1 lakh. Simply by 4 points you can change the range by 10 to 1 lakh. 1 lakh range of frequency can be accommodated in simple 4 lines of the log 10 to the base omega graph. So that is the beauty of taking log 10 graph for plotting the Bode plot. So the Bode plot is nothing but it is a graph between log 10 to the base omega versus magnitude and also log 10 to the base omega versus the phi or nothing but phase angle. That is called the Bode plot. That is called the Bode plot. Okay, so let's move deeper into the Bode plot. This also in your syllabus, my dear, so I think it's very important. It's very important. Okay, if you have any doubt you can ask. Until now, if you have any doubt you can ask. Okay, my dear, did you get it? Did you get it? Okay, so let's continue. Let's continue, my dears. Let's continue. Okay. First one. First case, my dear. You can discuss by case by case. Suppose GH is equal to K. But now we are going to discuss Bode plot for general functions. Bode plot for some general functions. So that after that a combination of these will be asked in real question, so that unless or until if you know the general situations, you can't solve for the combined situation, my dear. So that's why we are going to derive we are going to deal with what general expressions first, general terms first. Okay, come. So when GH is equal to K, GH is equal to K means the open loop gain is nothing but, my dear, simply a constant, Then what will be its Bode plot that we are going to discuss. What will be its Bode plot? So magnitude of GH is nothing but, my dear, simply K itself, right? And what will be the phase, my dear? It is simply 0. It is simply 0. Okay? So mod GH it can be simply represented with magnitude K. So what is M in dB? What is M in dB means? 20 log 10 to the base K. It is simply magnitude in quantity wise, but we need in dB means 20 log 10 to the base. That magnitude will give you the value of magnitude in dB. That's all. Then what will be our Bode plot? Bode plot is nothing but the graph between log 10 to the base omega versus magnitude in dB. So what you got magnitude in dB, my dear? 20 log 10 to the base K means the graph will be like this. This point will be what? 20 log 10 to the base K. So the constant which is a parallel to x-axis graph you will obtain. Parallel to x-axis graph will be obtained. Then, my dear, what is the slope of this graph? What is the slope of this graph? Slope of this graph will be nothing but either you can take y2 minus 1 by x2 minus x1 in case of what? The coordinates, x and y coordinates, or I can say that, my dear, slope will be nothing but dmdb divided by d log 10 to the base omega. Am I right, my dear? Am I right? Y coordinates divided by x coordinates derivative. y2 minus y1, I will use another step so that it will be very, very easy to understand. y2 minus y1 by x2 minus y1 also write like dy by dx na. also like dy by dx now, which is nothing but simply derivative of y coordinate divided by derivative of x coordinate. So derivative of y coordinate, my dear, here I can say in general, not here, general. Suppose you have mdb axis, mdb and log 10 to the base omega as two axes of a graph, then what will be its y term will be nothing but dmdb. Am I right, my dear? dmdb, dy instead of dmdb, because instead of this y it is mdb, instead of this x it is log 10 to the base d log 10 to the base omega. Okay, so the slope of the log 10 to the base omega versus mdb graph is nothing but d log 10 to the base omega, I mean as a denominator I am dmdb. That means d by d log 10 to the base omega of mdb, that's all. Simply we have to differentiate mdb with respect to log 10 to the base omega, that's all. That's all, my dear. We have to, what we have to do? We have to differentiate log 10 to the base, we have to differentiate mdb versus log 10 to the base omega, that's all. That's all. Is it clear, my dears? Is it clear? The concept is clear now? Okay. We have just started, my dear. Please understand from very basic level so that you can easily grab the concept and you can move. Then what will be the other graph? What will be the other? So now the slope will become what? Now the slope in this graph, what is the slope now? Slope now, what is the slope in this graph, my dear? There is no slope. It is a constant line, so there is no slope. There is no slope. Suppose the line is like this, parallel to y-axis means slope will be infinity. Parallel to x-axis means simply there is no change in y-coordinate, so 0 by something, 0 by something is nothing but 0. So the slope will be 0, and the unit of slope now in this Bode plot is nothing but 0 dB per decade. Very, very important, my dear. Very, very important. The unit is nothing but, see here, what is the unit? mdb means you will get a dB quantity. Divided by log 10 to the base omega means simply decade. Log 10 to the base omega means what is actually, it is a decade change now. It is a decade change, right? So you can always represent slope in Bode plot as dB per decade, my dear. dB per decade. It's very, very important concept. Very, very important concept. dB per decade. So what will be again log 10 to the base omega versus the phase angle phi. Is there any phase? Phase is 0 now. For constant, how can we calculate the phase angle, my dear? It is 0. So this will be the graph. This will be the graph. Log 10 to the base omega versus phi. It will be the graph. This will be the graph. Okay. So the concept you have to understand is that whenever the open loop transfer function is a constant, the slope will be 0. First thing, there will not be any slope. It will parallel to the x-axis, second term, and its phase angle will be simply 0. That's it. So that is the first case. Is it clear, my dears? Is it clear? Is it clear? Is it clear? Okay, can we move further? Two. Suppose GH is equal to S. Suppose you got an open loop GH is equal to S. S is nothing but what? S. Simply S means what? S means S by 1. So S is in numerator. So numerator represent the poles, no zeros, right? So S is equal to 0 means number of zeros at origin. Am I right, my dear? Number of zeros at origin. That is called S. So S is equal to, generally S raised to 1 means there is one number of zeros at the origin. Suppose S raised to 2 means 2 number of zeros. So generally Numerator will represent number of zeros at the origin. Am I right? Number of zeros at the origin. So now one number of zero at the origin. So simply you can say one number of zero at the origin. Okay, my dear. So let's continue. So the first step is again nothing but put s is equal to j omega. So what will be the magnitude now? Simply omega. Am I right, my dear? Simply omega. And what is the phase now? For j omega means 0 plus j omega. It is similar to 0 plus j omega. So what will be the phase angle? Tan inverse b by a, tan inverse omega by 0, tan inverse omega by 0, tan inverse infinity. What angle makes tan inverse infinity? Tan theta equal to infinity. What angle of theta make tan theta equal to infinity? Sin 90 by cos 90, 90. So phi is equal to 90 simply. Or simply other words, my dear, 1 by j omega you can take to numerator as minus 90 now. So it is already in the numerator, means j omega is simply plus 90. That way also you can think. That way also you can think. So you got magnitude. So what is magnitude in dB, my dear? Magnitude in dB, that is nothing but 20 log 10 to the base simply omega. 20 log 10 to the base simply omega. Okay. So we need these two quantities for plotting the graph. Okay. So what will be the graph now? So graph is nothing but log 10 to the base omega versus mdb. mdb you got like, simply you can take mdb. Okay, mdb. Okay, my dear. And 20 log 10 to the base omega. Okay, my dear. So yeah. So what is the slope of the graph, my dear? What is the slope of the graph? Slope is nothing but d mdb divided by d log 10 to the base omega. That means you have to differentiate mdb with respect to log 10 to the base omega. That is nothing but, my dear, d by d of log 10 to the base omega of what? 20 log 10 to the base omega. What you will get? What you will get, my dear? You have to differentiate this with respect to that. It is simply 20 na? 20 dB per decade. 20 dB per decade will be the slope. Plus 20 dB per decade will be the slope. And what happens? See, my dear, in log 10 versus log 10 omega versus mdb graph, there is no point in the 0, because log 10 to the base 0, I already told you, it is not defined. But I already told you one thing, my dear. Log 10 to the base 0.1 is defined. It is nothing but minus 1. It is nothing but minus 1. So what, suppose here you can't take for omega equal to 0, but you can take a small change like omega equal to 1. I mean this axis, this point, my dear, this point, always this axis, my dear, this point, this is log 10 to the base omega, shorten. At for what value of omega up to you can shorten? Omega equal to 0 is not defined now. So just above that value, omega equal to 0.1, it is defined. Omega equal to 0.1 is defined. So you can take omega equal to 0.1 as this point. Omega equal to 0.1 as this point. Then what is the magnitude at omega equal to 0.1? You have to note. So put omega equal to 0.1 here. So mdb at omega equal to 0.1. What is that, my dear? 20 log 10 to the base 0.1. It is nothing but minus 20 dB. So you can take that at omega equal to 0.1, my dear, minus 20 dB as the starting point, and with the slope of 20 dB per second. 20 dB per decade, not second, decade. It's going. And this point now, my dear, this is nothing but omega equal to 0 or 1. So that is why this point is taken as omega equal to 1 means the gain now, my dear, the gain is 0 here. The gain is 0 here. That means log 1 is equal to what? 0. So only it happen when omega equal to 1. So that is why this point is called omega equal to 1, this point is called omega equal to 0, and so all goes on increasing. So this will be the graph. This will be the Bode plot. This will be the Bode plot of GH equal to S. GH equal to S. So in general, my dear, in general, I can plot a graph like this. Dear, this is very deep concept, very difficult to understand, I know that, but please watch 2-3 times this video so that you can easily understand. There is no change in this, there is no change in this. See, in general, suppose you have GH is equal to S raised to N. This is simply S raised to 1. Suppose you have S raised to N, my dear, then the starting magnitude, it will be minus 20 into N dB. And the slope, my dear, it is nothing but plus 20 into N dB per decade. So that will be the Bode plot. That will be the Bode plot. For this is GS equal to for S, you can solve like this. For general, suppose S raised to N means you have to multiply 20 into N. For example, suppose S square. What will be the Bode plot for S square? Minus 40 with plus 40 dB per decade graph. That's all. What will be the what Bode plot for S cube? You don't want to do all this. You have a general idea now. You have a general idea now. So you can simply do S cube means minus 60 will be the starting point with the 60 dB per decade will be the slope. No change in this point. It's a no change in that point, my dear. It's same. It's same. Is it clear? Is it clear? Okay. So as a conclusion, you can take that one pole, one zero make slope plus 20 dB per decade and magnitude 20 minus 20 dB, or not magnitude, you can say the starting magnitude. Starting magnitude will be minus 20 dB. 10. For 20, slope will be 40 dB per decade plus 40 dB per decade. Plus 40 means nothing but it is increasing slope, my dear. It's increasing slope, that's all. Plus 40. Plus 40 means it's increasing slope, that's all. It's increasing slope. See my dears. Is it clear? Is it clear? Can we go to next session? So this will be, you have to make it in a box, my dear. This you have to make it in a box. It's very important. Very important. That means the addition of 10 will make what? Plus 20 dB per decade slope with the initial minus 20 dB. That's all. So same manner, this is nothing but S0 at the origin, my dear. So what happened? S0 at the pole. S0 at the pole. Sub of G is equal to 1 by S means what, my dear? S0 at the, a pole at the origin. So I can say that a pole at the origin. There A0 at the origin, or one number of 0, A simply A0 at the origin. Now 1 by S means a pole at the origin. So what will be its Bode plot? Let's check. So what will be the first step, my dear? Simply GH is equal to 1 by S is equal to J omega. My dear, you have to do a common step for every problem when you are solving polar plot, Bode plot and gain margin and phase margin. The first step is nothing but put S equal to J omega and magnitude and phase. You have to calculate. It's common. It's common in these three plots and I mean frequency analysis. It's all frequency analysis, right? So 1 by J omega. So what will be the magnitude, my dear? What will be the magnitude? Simply what? Simply 1 by omega, right? Or what will be M in dB? 20 log 10 to the base 1 by omega, which is nothing but minus 20 log 10 to the base omega. because 1 by omega is nothing but omega raised to minus 1. That minus 1 come here, it will be minus 20 log 10 to the base omega. Right? So what will be the phase angle phi? For 1 by j omega, the phase angle will be 9 minus 90 degree. So you have the phase angle as well as m in dB. So can you plot the graph, my dear? Can you plot the graph? The graph is nothing but log 10 to the base omega versus magnitude in dB. Am I right? Magnitude in dB. So this is nothing but omega to 0.1. Magnitude equal to 0.1. Okay. So there also you got minus 20 d log 10 to the base omega na. So it is a generalized omega term na. So you have to particularly take for omega to 0.1 means you can substitute here at omega equal to 0.1. What will be mdb? Magnitude in dB. It's nothing but 20 log 10 to the base 0.1. It is nothing but minus 20. Oh, he is already minus 20 na. So minus and minus plus 20. So it will be plus 20 dB. And what is the slope now? Slope is nothing but, my dear, d mdb divided by d log 10 to the base omega, which means we have to differentiate mdb with respect to log 10 to the base omega. So simply you have to differentiate what? d 20 log minus 20 log 10 to the base omega whole divided by d log 10 to the base omega. So the answer will be simply minus 20 dB per decade, because it deals with what? Log 10 na? So dB per decade always. So now you have a certain idea, my dear. So similar way, what will be the starting point mdb at a point omega to 0.1 plus 20. So this will be plus 20. What is the slope, my dear? 20 dB per decade na? So minus 20 dB per decade. This will be the slope. So this can be right like minus 20 dB per decade. And this one is nothing but omega equal to 1. That's it. Gain is equal to 0. So now you got 1 by s condition. So I can say that in general, that means 1 by s raised to n. Suppose for 1 by s raised to n, the nature of the graph will be nothing but, this is mdb graph. The starting point will be what, my dear? 20n dB. And the slope will be what, my dear? Minus 20n dB per decade. And this will be, there is no change in this point, my dear. This will be log 10 to the base omega. So that is for general case. So you can add here one term, like one box term. One pole can make a slope minus 20 dB per decade, and with the starting magnitude 20 dB. One pole can make this much change. My dear. One pole can. That means one pole at origin, my dear. At origin is very, very important. Rather than origin condition is there, that I will discuss later. One pole at the origin, and previous case na, there is one more box I added na in the previous question. It is, you just add one more thing, 1 0 at origin. So at origin this condition is applicable. Rather than origin na, that we will discuss now. That we will discuss later. Okay. So this is the magnitude versus log 10. What is the phase angle, my dear? Simply, what is the log 10 basis omega versus phase angle graph? The phase angle is nothing but minus 90 na? So it will be like this, minus 90. In previous case there was plus 90, that's all, plus 90. This phase angle versus this one is not that much important. Given this point is very, very important. Okay, so the 0 at the origin make 20 dB per decade, but initial point will be minus 20n, generally minus 20n and plus 20n dB per decade. Pole at the origin make plus 20 yen at the starting point, but minus 20 yen dB per decade as the slot. So pole means polling. Pole, you can imagine like okay, you can connect in any way. Okay, you can, it's your freedom. Okay. Okay, next write a question, my dear. Write question. Draw the Bode plot. Draw the Bode plot. Draw the Bode plot. So general term now. If you start to suppose you substitute S equal to J omega, and if you continue like that, it will take more and more time, my dear. I will say one easy step. First, you just draw this thing. Log 10 to the base omega versus m in dB. Okay. So we know that for S is to n, that means suppose you forget now, just now you forget about 100, it's a constant now, you just forget about simply 1 by S raised to 8 now. It is a general term, must be 1 by S raised to n. S raised to n is nothing but pole, my dear. So pole means whenever you heard the name pole, you remember like this, pole, your voice also decreasing now, pole. So the curve will be like this. You imagine in that way. That's the way I have already reminded. Okay, that's fine. Okay, so S raised to 8 means what will be the starting point? For 8 poles, what will be the starting point, my dear? 160, am I right? 160 dB. 8 into 20, 160 dB. What will be the slope, my dear? It is 8 into 20. That is 160 dB per decade. This is omega equal to 1. This is omega equal to 0.1. Is that over? What about this 100, my dear? We already discussed the first step. GH is equal to K graph. GH is equal to K graph means there is no slope point, my dear. Slope is 0. That means the 100 cannot contribute anything to the slope. The 100 can only contribute to what? The initial magnitude, my dear. The initial magnitude. Because its slope is 0. So it moves accordingly with other terms. It doesn't exist alone. If it exists alone, my dear, the constant, there will be a magnitude of constant in nature. 20 log 10 to the base k. It is a constant term. It's a constant term, my dear. There will not be any. Whenever you change any frequency, you can change there is a constant term. There is a constant. That means there will be the initial point only that exists. Whenever you increase the frequency, decrease with that, they always will be there. The plot will be always there. That means for 100, my dear, then what will be the gain contributed by that 100 constant? See that gain contributed by 100 will be equal to what? M in dB is nothing but, my dear, 20 log 10 to the base 100, which is nothing but 20 log 10 to the base 10 square, which is nothing but 40 dB. 20 log 2 will come here, 20 log 10 times 1, so 40 dB. So 40 dB gain can be added to the initial gain by this 100. Nothing more, nothing else it can contribute. Nothing more, nothing less it can contribute. Only a 40 dB at the initial stage can contribute by the 100. An initial gain of 40 dB can be contributed by this 100 on the Bode plot. That's all. You never think like every point there will be 100. Not, my dear, no, because of the effect of this landing, its effect will be only at the initial point. Suppose you plot a graph between 100, only 100 for all log 10 to the base omega, means you may get a graph like this parallel to x-axis. But whenever there is an effect of this 1 by s raised to 8 now, the graph will not be this much, but this will be this much. You can imagine like this, my dear. So this is nothing but the previous just 100 graph. This was the 100 graph initially. When you add a 8 number of poles at the origin, that means at the origin might be simply better. Now you add 1, 2, 3, 4, 5, 6, 7, 8 number of poles you added in the origin, my dears. What happened then? The graph initially, this is slant, it deformed like this. You may have a doubt, Arey sir, you draw the graph of a constant like this, but now there is no dash line. Where was the dash line? Arey my dear, that dash line now. That dash line started slanting, slanted like this much, 118, 160 dB per decade, due to the effect of this s raised to 8, which means addition of 8 number of poles to the origin. Continuously you add 8 number of poles to the origin, makes the standing or makes the slanting of the 100 line to like this. That's all, my dear. And the addition of that pole now, it contributes some more magnitude also. That magnitude was 160 dB. That magnitude is 160 dB. So in perfect, the complete Bode plot will be nothing but, my dear, 160 plus 40, which is nothing but 200 dB will be the starting point of that plot. 200 dB, this point is nothing but 200 dB. 200 dB will be the starting point. But how it is obtained? Like this it is obtained. That means the gain contributed by 100 is nothing but 40 dB, and the gain by 8 number of poles on the origin is what else? 160 dB. So overall gain will be 200 dB. That's all. More than this, I can't say anything, my dear. This is the utmost simplicity I can explain. So even if you have doubt, means I don't know how to say. Okay. And if you see somewhere else easier than this, you can definitely go and check there. You can study there. No issues there. But the thing is, you should study. That's my aim. I don't say please always follow me. Always follow my channel. Definitely I won't say, my dear, because knowledge grabbing is the aim. You can grab knowledge from anywhere. I am not compelling you, Ray, you can follow only my channel. No, you can check many channels, you can refer many number of channels. But the ultimate aim is nothing but you should have the idea. That's all. You should have the idea. That's my aim. Is it clear, my dears? Is it clear? So did you get the idea? How can we draw a Bode plot? No, a small idea. Small idea did you get? Okay. And next is nothing but, my dear, net I think is 5 now. Suppose GH equal to 1 by 1 plus S2, which is nothing but, my dear, there you discussed n number of poles at the origin. Now rather than origin, 1 plus S2 means there is poles, my dear, there are poles but not at the origin. 1 plus S2 means the poles will be minus 1 by 2, na? Yes, 1 plus S2 is equal to 0 means S is equal to minus 1 by 2. So minus 1 by 2 pole may exist, not at the origin. So now it is nothing but poles rather than origin. So that is the general case we are going to discuss. Sorry, my dear. It is nothing but 1 by 1 plus j omega into tau. So what will be the magnitude, my dear? 1 divided by root of 1 plus omega square tau square. What will be the phase angle phi? We always forgot to draw the phase angle versus log 10 omega axis now. You draw here always because that is very easy now. It will be definitely you will give an answer. Now it will be minus tan inverse omega tau by 1. That is the phase angle. So m in dB will be what, my dear? M in dB will be 20 log 10 to the base this one 1 by 1 plus omega square tau square root of. So it will be nothing but 20 log 10 to the base root of 1 plus omega square tau square raised to minus 1. So it will be simply minus 20 log 10 to the base root of omega square tau square plus 1, or simply you can raise minus 20 into 1 by 2 log 10 to the base omega square tau square plus 1. Array, this omega square tau square plus 1, the whole raised to 1 by 2 na, root of that 1 by 2 come here, so 20 into 1 by 2, that's all, minus 10 log 10 to the base 1 plus omega square tau square. So that will be the general equation for m in dB. Okay, my dear. So it is a general omega square tau square now. So the value of omega square tan square may be anything. So you have to consider for some cases. Case 1. Let omega square tau square very less than 1. Very less than 1. Very less than 1. Suppose omega square tau square very less than 1, which is implies that omega tau less than simply 1. Omega square tau square very less than 1 means omega tau less than 1 or omega less than 1 by tau. Suppose omega square tau square very less than means what will be the m in dB, my dear? M in dB will be equal to minus 10 log 10 to the base, simply this 1 plus omega square tau square now, this omega tau square is very less than 1 means you can neglect this omega square tau square because it's very less than 1. So compared to 1 it is very less. So you can simply take log 1. So the answer will be simply 0 dB, my dear, simply 0 dB. Suppose the omega square tau square less than 1. Okay. In problem very clear. And leave the phase angle concept, my dear. It's not that much important. And the case 2, omega square tau square very greater than 1, which means or omega tau simply greater than 1 or omega greater than 1 by tau. Omega greater than 1 by tau. What happens then? m dB minus 10 log 10 to the base simply omega square tau square, na? Correct, na? So it will be simply minus 20 log 10 to the base omega tau, or simply minus 20 log 10 to the base omega minus 20 log 10 to the base tau. This is always a constant, right? This can be varying. So what will be the slope? D by d of log 10 to the base omega with respect to this much, minus 20 log 10 to the base omega minus 20 log 10 to the base tau. So the answer will be simply minus 20 dB per decade. And in case 1, what will be the slope now? Case 1, what will be the slope now? 0 dB per, how can we take the source? Simply 0 dB per decade. 0 dB per decade. So see the beauty here, my dear. See the beauty again here. See the beauty here. That means at omega less than 1 by t, slope is equal to 0. Okay, and magnitude also 0 dB. Slope equal to 0, magnitude also 0 dB. Magnitude also 0 dB. At omega greater than 1 by 2, slope suddenly changed, my dear. It will be minus 20 dB per decade. And what is the magnitude? Magnitude will be this much, minus 20 log 10 to the base omega tau. This is the magnitude. So what I infer from this is, at omega less than 1 by t to omega greater than 1 by t, the slope suddenly changed from 0 to minus 20 0 to minus 20 dB per decade. From omega, suppose you take like this, you take an axis like this, maybe. Here the value of omega and equal to 1 by tau. Here is omega equal to 1 by tau. So less than omega less than 1 by tau, my dear, this value, the slope was 0. Fine, very good, I am happy, okay. At omega equal to 1 by 2 or greater than 1 by 2 means after this, suddenly the slope changed to minus 20 dB per decade. So at omega equal to 1 by tau is called the corner frequency. There the slope changing happens. But that slope changing, my dear, it is not exactly from 0 to directly to 20 dB per decade. There is some error happens. That means at 20 dB, I mean at omega equal to 1 by t, error at corner frequency you can write. That means magnitude will be nothing but, my dear, what? M dB at omega equal to 1 by tau you have to calculate, which is nothing but minus 20 log 10 to the base omega equal to 1 by tau, 1 by tau, omega to 1 by tau, 1 by tau into tau, 1 by tau square into tau square, correct na? Omega square tau square na. So sorry, 20 means simply omega tau, 20 means simply omega tau. So it will be another cancel, 20 log 10 to the base 1, 20 log 10 to the base 1. Wait, sorry. Yes, it is a concept, it is a general equation, not is na. General equation is actually 1 plus omega square tau square na. It was the general equation na. That was the general equation. We assumed omega square tau square less than tau. That condition you assumed case 1, case 2, etc. General equation was nothing but 20 minus 10 log 10 to the base 1 plus omega square tau square. That na initially you discussed, right? So it will become, my dear, minus 10 log 10 to the base 1 plus omega square tau square is nothing but omega square is tau square is nothing but, my dear, what? Omega is 1 by tau na, 1 by tau square into tau square. So tau square cancel, minus 10 log 10 to the base 2. It is nothing but log 2 is nothing but, my dear, 0.3. So it will become minus 3 dB. So minus 3 dB. Error will be there at the point omega equal to 1 by 2, which means what is the meaning of this, my dear? What is the meaning of this step? That means there is the m magnitude is directly 0 na. Magnitude is 0 na. Here the magnitude is nothing but 20 log 10 to the base omega 2. At greater than this point, this point always exists like 20 log 10 to the base omega tau. But at omega equal to tau, my dear, there will be a magnitude of minus 3 dB. which cannot be indicated by this figure, which cannot be indicated by this figure, which cannot be included in this figure. That is a loss. That is a negligible loss actually, not that much loss, because we are dealing with 160 dB, 200 dB, 500 dB, etc. So minus 3 dB is a loss at omega equal to 1 by 8. That's all. So in examination there is a possibility of asking what is the loss at a corner frequency. Only minus 3 dB change. Minus 3 dB change. Okay. Minus 3 dB change. Minus 3 dB change. It will be applicable when in electronics I am taking. When I am taking electronics, it will be clear. More and more clear. Okay. Is it clear, my dear? So this is the case of 1 by 1 plus S2. 1 by 1 plus S2. Next. Next, suppose you have GH equal to 1 plus S2, my dear, simply, which is nothing but zeros rather than origin. Zeros rather than origin. What happened then? Again, GH is equal to what, my dear? 1 plus G omega into 2. And magnitude will be nothing but root of 1 plus omega square tau square, and m in dB is nothing but, my dear, 20 log 10 to the base root of 1 plus omega square tau square. So it is nothing but, my dear, 20 into 1 by 2 log 10 to the base 1 plus omega square tau square, 10 log 10 to the base 1 plus omega square tau square. Again the same. So what will be phase angle phi? Tan inverse omega tau. There minus tan inverse omega tau, now this tan inverse omega tau. So again, if you are plotting a graph like this, my dear, same case you can take, like you can consider for case 1 and case 2. Case 1 and case 2, my dear. Okay, I will tell you. Case 1. Omega square tau square very less than 1, or omega t very less than, simply less than 1, or tau or omega simply less than 1 by tau, or omega less than 1 by tau. At this kind of omega square tau square very less than 1 means you can take the magnitude again 0 dB, because log 1 will come now. 10 log 10 to the base, this is very small, means you can take log 1 as directly. So log 1 is equal to 0 dB. What is the slope also? 0 dB per decade. Because mdB there is no differentiation for 0. And what is the case 2? Omega square tau square very greater than 1, or omega tau simply greater than 1, or omega greater than 1 by tau. Omega greater than 1 by tau. What will be the MdB? What will be the MdB? It is nothing but this one, my dear. 10 log 10 to the base omega square tau square, because it's very greater than 1 means you can neglect 1 and you can directly substitute omega square tau square. So it will be simply 20 log 10 to the base omega tau. It's nothing but 20 log 10 to the base omega plus 20 log 10 to the base tau. 20 log 10 to the base tau. So what will be the slope, my dear? D by D log 10 to the base omega of this much. So only the answer will be So the only answer will be 20 dB per decade. So here also, see my dear, when omega tau very less than 1 or simply omega less than 1 by tau, I can say like at omega less than 1 by tau, mdb was 0 dB and slope was 0 dB per decade. At omega greater than 1 by tau, in the second case, mdb is this much, 20 log 10 and slope was 20 dB per decade. Right now 20 dB per decade. So what you infer from this, my dear, these 2 points, what you infer from? Again the same condition at omega equal to 1 by tau. If you draw a graph like this, okay, up to omega equal to 1 by tau, my dear, omega less than 1 by tau, the gain was 0, there is no change, the gain was 0, okay, I'm very happy because no need to find, slope also 0, so slope also 0. At omega equal to 1 by tau, or after omega equal to 1 by tau, what happened means, there is a sudden slope increase 20 dB per decade with magnitude, right, some magnitude also there, but slope will be suddenly decreases to 20 dB per decade. So again at omega equal to 1 by t, a error will be happen. So you can say that error at omega equal to 1 by tau will be same as that of equal to plus 3 dB, not minus 3 dB. There now it is plus 3 dB because there was it's minus 3 dB now. So now it will be plus 3 dB. Plus 3 dB. Error at corner frequency. So this will be a graph, my dear, actually log 10 to the base omega versus mdb graph. There also you change the axis like this. There also you change the axis as log 10 to the base omega versus mdb. Okay, my dear, that's all today. We will meet again tomorrow. I know it's very difficult to understand, but you have to study, right? You have to study. Okay, so thank you all. Have a nice day.